In this video, we're going to look at exceptions to the octet rule when drawing Lewis structures. We're going to look specifically at something called free radicals. Free radicals are molecules that have an odd number of electrons. Now, you won't know that you have a free radical to begin with. Only while you're doing the NASA table calculation will you determine that something might be a free radical. So an example of a substance that is a free radical is the substance nitrogen monoxide, NO. So let's go through this process and I will show you at the moment that you realize you have a free radical and then what to do with it. So let's do our NASA table, NASA, in one column, put our equal sign, and then let's make two columns, one for nitrogen and one for oxygen, each of our element types. And we'll go through the NASA table to begin with like normal. So we have one nitrogen, it wants an octet of 8 electrons. We have one oxygen and it wants an octet of 8, which is a total of 16 electrons. And then we'll go through its available valence electrons. For the one nitrogen, it has 5 valence from group 5. And one oxygen has 6 valence electrons available. And when you sum this up, you end up getting a value of 11. Now in the previous video where I showed you how to do the Lewis structure and calculate the NASA table with an ion, anytime I said that if you calculated for this first column of available electrons, if this value ended up being odd, then you needed to adjust that value based on the charge. We'll see that you would pretty much be in that situation right now, except for you go and look at the substance and there is no charge. So there's no way to adjust that value. So at this point, this is where you realize, oh, you have a free radical. And so what you do is just continue. So keep calculating every component of the rest of the NASA table, and then I will show you what to do with your values. And so we're going to go through and calculate our S, which is N minus A, which is 16 minus 11, which ends up giving you a value of 5. And then you're going to calculate the last additional A, which is going to be available minus shared, which will be 11 minus 5, which will give you 6. And these last two numbers that you see here are the numbers that you're going to pair, right? So you're going to go through and you're going to divide by 2. Now, where you get to that situation is you divide by 2, but it must be evenly. So that means for your 5 divided by 2 here, it can only go into that 2 times evenly, which means that's how many bonding pairs will be there. And then whatever is left over, you'll have as one additional electron. And we'll put that in as a dot. And then here you'll get 3 lone pairs for the 6 divided by 2. Okay? And at this point, what you can do now is start to build your structure, and you just think of things as normal. So we'll have our N attached to our oxygen. Now, since you only have 2 atoms here, there's not really technically a center atom here, and there's not going to be really any symmetry associated with it, but we just go with what we have, and we're just going to try to make our values that we have calculated in our NASA table to add up to what we see in our structure. So this time we have an additional thing that we're going to try to make sure that we have placed into our structure. So we have a total of 2 bonding pairs. Well, we only have one written, so we're going to draw a second bonding pair to make sure that we match that up. And there's only one place to put it, so we put that as a double covalent bond. And then what I want you to do is go and just place your lone pairs. Let's kind of think of the one extra electron last. Now, if you started with nitrogen, then you would think, oh, I need to place 2 lone pairs, and then you move over to oxygen, and then you're like, oh, that needs 2 lone pairs, but see, there's only 3 total, there's not 4. So what you're going to do at this point with free radicals is you're going to try to add the lone pairs to the atoms that have a higher electronegativity value first. since we don't really have a center atom as well. And so it turns out that oxygen has a 3.5 value of electronegativity. Nitrogen's is lower. And so we're going to put our lone pairs and fill the octet with oxygen first. So we're going to put 2 lone pairs with oxygen. It has now a full octet. And we'll put our 3rd lone pair with nitrogen. And now it doesn't have an octet, but it's pretty close. It's 6. And so we've got those 3 lone pairs taken care of. Now we need to put our extra 1 electron somewhere. And we're going to try to put it on something that hasn't filled to an octet yet, but we'll get it close to. And so we're just going to put that 1 electron with nitrogen, and now it has 7. This is an exception to the octet rule in the sense that nitrogen does not have an octet. And it's only in the situation where you would have a free radical that gives you that situation. Okay, so here is one of the exceptions to the octet rule.